factoring by grouping. Now, grouping is basically taking out GCFs, greatest common factors. And typically we look for greatest common factors by looking at all terms. Now, the greatest common factor for 5, 10, 3, and 6 is going to be 1. So there's no real GCF to take out of this. But if we take out a GCF just out of the first two and out of just the last two, we can get something more significant than the number 1. So the GCF out of the first two would be a 5. Okay, because you take 5 and 10 here. And it would also be an x squared. So we're going to take the 5 and x squared out as a GCF just out of the first two. So 5x squared. And now what's left here for the first two terms will be x squared minus 2. Okay. Let's see. Did I do that right? No, that'll be just x minus 2. X minus 2. Okay, so x minus 2. Now I'm going to go to the last two terms here, and I'm going to look for a GCF there. The GCF here will be 3. So I'm going to take the 3 out. And since this part right here is adding to this, I'm going to put a plus here, take the 3 out, and then put the remaining terms here. So when you take a 3 out of here, you get an x minus 2. Okay, so we're taking GCFs out in groups. Now, if you look at the entire problem that we have now, the entire problem does have a GCF. The GCF that everybody has right now is an x minus 2. I can take the x minus 2 out of both of these here as a and put it out to the side. So this is now the new GCF. Let's take this out, x minus 2, and that leaves behind the 5x squared and the plus 3. And we've just converted this into two binomials. Okay. And just to give you a quick check to show you that this binomial times this binomial actually gives you this right here, I'm going to say x times both of these. So x times this is going to give us 5x to the third power, and x times this is going to give us 3x. Okay, now I'm going to multiply both of these by negative 2. Negative 2 times this one right here will give me negative 10x squared. I've got my little plus here. Okay. And negative 2 times this gives me negative 6. And when I rearrange this to go from greatest to least, I have 5x to the third power. The next will be negative 10x squared, then the 3x, and then down to negative 6. And you can see that this does match with the original. So these two binomials really are the factors. So now we're factoring out GCFs now in groups rather than the entire expression. Try it again. This expression, if you look at the entirety, the GCF of the whole thing is 1. But the GCF for just the first two is going to be, let's see, I believe 4x squared. So let's take out the 4x squared. So 4x squared, and that's going to leave behind a 3x plus 7. Now, there's also a GCF for these last two right here that I can take out. And these two, the GCF will be 5. So let's take that out. So plus 5. And now let's see what's left. This is going to be a 3x and plus a 7. And you notice that now with the whole expression, we do now have two GCFs. Oh, sorry, a GCF in both terms. So we're going to take this GCF right here, greatest common factor, out. 3x plus 7. And that will leave behind a binomial of 4x squared plus 5. All right, let's go to this one. Okay, throughout the entire problem, the entire GCF is 1. So we're not going to bother taking a 1 out. But sometimes we can. Sometimes we can. But not out of the entire expression. So the GCF, just for the first two, will be a 3x squared. So we're going to take that out. So 3x squared out of the first two will leave behind a 4x minus 3. Okay. Now, when we get the next two pieces right here, you'll notice that there is no GCF here other than the number 1. Well, we're going to go ahead and take out the number 1 because it really is a GCF, greatest common factor, and we're going to see what we get. So plus 1, and the GCF of these two remains 4x minus 3. And you notice that this binomial and this binomial match. These are greatest common factors. We can take the 4x minus 3s out as a GCF. And that leaves behind the binomial that has the 3x squared and plus 1 in it. Okay. This one here. Okay. The GCF for the entire problem is going to be 1, so that's useless taking that out. But the GCF for just the first two is going to be, well, that should be squared. For the first two is going to be x squared. So let's take the x squared out. And that leaves behind x minus 1. Okay. Now, the GCF for these two right here will be 2. So we'll take the 2 out. Still add, possibly, so we're still adding. So plus 2 parentheses. And we'll take the 2 out, we get x minus 1. Okay, and now we see that we have yet another GCF, which is x minus 1. So let's take that out. X minus 1. And it'll leave behind the binomial of x squared plus 2. Okay.